Okay, all right, let's get to it. Let's talk a little bit about chip seals real quick. How many of you guys been on a chip seal job before? Okay, good many bit. All right, good, good. So some of this might be pretty basic for you guys. Might be a refresher, might be boring. We're gonna hopefully get into some topics. I know when Brian starts to speak about distributors and chip spreaders, that maybe really get into the weeds. So if you do have a question while we go through this, I mean, feel free to stop us, ask a question. This is very informal. Nothing formal about this, okay? So chip seal, all it is also known as a seal coat. All it consists of is binder being placed on a roadway and aggregate being placed on top of binder. That's it. I mean, that's pretty simple. It sounds simple, right? But sometimes it's not that simple when we construct these things. There's just so many variables, and we'll talk a bunch about those variables today. All right, so what's the benefits of chip seals? Well, it's going to increase the skid resistance. We're going to seal minor cracks. Okay, we're not talking about major, just minor cracks, 1/4 inch below. It's going to extend the average service life 5 to 10 years, and that's a pretty big range there, 5 to 10 years, but it's really dependent on the existing surface condition, right? Because sometimes we have a surface that's maybe not in its optimal state to put a chip seal on, but we do it anyway because we just need to. It might be more of a stopgap measure, okay? So that's why this range is kind of so big. It really just depends, okay? It's going to correct deficiencies, rattling, flushing, aged, oxidized pavements. What does it not do? It does not provide structure. So anybody over there yesterday in a micro slurry, did they talk about that over there too? I mean, pavement preservation is not there really to provide structure. Okay, so we're not going to increase the load bearing capacity, nothing like that. We're not really going to smooth out a rough ride. Usually a lot of times if your road's rough, you put a chip seal on, it's going to be rough again. Okay? It's not going to bridge cracks wider than 1/4 inch. And then any ruts you have out there, it really needs to be very minimal rutting. I mean, we start getting into 1/2 inch or greater, what's going to happen? Where's all your emulsion going to go? Or binder? Into the rut. And then what are we going to have? We're going to have a bleeding situation, a bleeding chip seal in the wheel pass, okay? So there's just some pictures of poor candidates up there. I know you can't see the ruler, but that's actually a crack that's greater than 1/4 inch. And then you see severely rutted pavement on the top right, and then just structural issues. I mean, this goes for any treatment that you'll probably see or talk about this week, is we need to make sure we have a good base. A fog seal is not going to correct structural issues right there. I had a county one time call me out, wanted a fog seal road just like that. Want to know if that would work. I had to turn it black. Yeah, it's probably not going to work out very well for you, but yeah, we can do that. If you really want to waste your money, we need to make sure we have a good base structure out there. So there's just some of the candidates that are good. Minor cracking, like I said, 1/4 inch less, loss of fines, really slight flushing, oxidation, and loss of friction. Okay, so that chip seal is going to give you, should give you great friction numbers. Anybody ever seen this curve before? Golly, this curve again. This curve again. The Kendall curve. Kendall curve. So all it just shows, we just talk about this to people all the time, about the service life or the age of your pavement. And once it gets about 75% of its life, it really starts dropping off a cliff, okay? So where do we really want to treat it? We want to treat it at the top of that curve, right? Whether it's micro, slurry, crack, whatever, fog, we want to treat it at the top of the curve so we can spend our money very wisely, very minimal amount. I think Scott Bartlett had a great presentation on his program, and a lot of his treatments here are at the top of the curve. That's why he can improve his PCI of his network. But sometimes we have a little stopgap measure, and I know when we were up in Fairfield, we talked about this summer with Scotty Bartlett. Sometimes you just got to do that. Sometimes it's just no choice. You don't want to, but you might have to do a stopgap measure. And it's going to cost you a little bit more, but you can see what happens, right? It's going to go up initially, but then it's going to start dropping off pretty quick. I mean, the warts start to show themselves really, really quick in that. But hey, if it gets you 4 years, 3 years, 5 years, and that's all you're expecting, then that's good. That's good. It's all about the expectations of what you're wanting out of this treatment. If you do a stopgap measure with a chip seal and you're expecting 10 years, you're going to be disappointed, very disappointed, okay? So you can see where chip seals fall, that good to fair category. Some of the treatments above that, below that, just showing you there where all the treatments fit on the curve. All right, so let's move on here to material selection. Let's talk about aggregate first. Okay, so what are the functions of all this aggregate we're going to put out on the road? One is just to resist, traffic abrasion, something for the wheels to drive on, improve the surface friction. I mean, it's just there to really let you go across that road. What the most important part probably is below that, that seals the road. Okay, but what kind of aggregate do we want? Well, here's some of the factors that you probably want to look at or needs to be a part of a spec for aggregate. Type, particle shape, toughness, soundness, gradation, cleanliness, and then absorption. Okay, so type. What would be an example of a natural aggregate? Granite, or limestone, all right? Something we find in gravel in some places. That's natural. What's synthetic? Yeah, maybe lightweight aggregate, something like that. Yep, that's synthetic. So both of these will work. It just depends on what's really locally available. I mean, everybody knows it usually in their area what's available, okay? So the next part is the gradation. And this is where it gets a little bit tricky. And you can see in this picture here between a single size aggregate versus a graded aggregate that has a lot of different sizes in it. So how would that affect us in a chip seal? Well, you can see right here, well, I don't know if my laser pointer will go that far, how we got little rocks, big rocks all over the place. But look where the binder is. We've got some of these rocks that have binder all the way to the top. We've got some binder that's barely up halfway on the big rock. So are our chances pretty good that that rock's going to stay? Probably not. And you can see how they're all wedged up against each other. They could end up popping some aggregate out. As a roller goes over it, a wheel goes over it, could pop it out. Okay? What we would love to see is this top picture where it's all the same size. Now, is that possible all the time? No, because it does probably cost more money to get a single size aggregate. So a lot of times you have to do with whatever you have. And sometimes it is this. But if we can minimize that gradation and I think we have one in our ISA guideline, and then AASHTO has one as well that's pretty similar, we can minimize that and give us a better chance of success. Also, another big thing is the flat and elongated. So if that's not part of a spec, it needs to be, because of this right here in this picture. You can see over here on this side, these are flat and elongated pieces of aggregate that when they stick up, when they're standing up, they look like they're okay. They got enough binder on them. It's going to stick. It'll be okay. But when the wheel hits it, whether it's a roller or the vehicle, what happens? What am I going to have now? What is my road going to look like? It's going to look black. It's going to be bleeding chip seal. I mean, I went from where it looked okay to now it's all flat, and now it's covered in binder. It's just basically drowning in binder. Okay? So we need to minimize the flat and elongated. Big part of the spec. Okay? We would like that, like we said, more cubicle sized. Round and angular. So we've had some situations. Has anybody used pea gravel or gravel just for chip seals before? Crushed gravel? Anybody? We've seen it, yeah, I've seen it some. Not a lot, but we have seen it some. You need to make sure it's crushed and get some fractured faces. But the reason why, if you just put, a little pea gravel out there, the roundness of it, it's just really susceptible to rolling as you put a tire on it. It just roll off. Okay, so we want to try it. We'd like it to be more angular in nature. This is probably a big one right here. Dust. So if we have a real dusty aggregate, and I have a binder down there, and we apply this aggregate, what is going to attach to my binder? The dust. Where's my rock going to end up? On the side of the road. Everything you paid for, the sweeper's going to just put it off on the side of the road. Okay? So we need to make sure we minimize that dust, and usually 1% or less is what we're shooting for. You start going up to 2, that doesn't seem like a lot, it's a lot. Going up to 2. And then we get up higher than that. If you can put your hand in a stockpile and have dirt between your fingers, that's a little bit too much. Yeah, that's more than 2. Okay? We've had some that have to wet their stockpile to try to keep the dust down. And that's fine as well. Okay? So dust is a big deal. Toughness and soundness, if we're in those freeze-thaw areas, you want to do some soundness tests. We want to make sure on the LA abrasion that's going to resist the abrasion and degradation and just polishing. So this is a picture of the LA abrasion machine. We just want to make sure that aggregate is sound and tough. And then absorption. The more absorptive that aggregate is, the more binder we have to put down. All right? Because it's going into the aggregate. So we need to know that up front if that's the case. Sometimes we have to use pre-coated aggregates. Usually it's in a hot applied situation where we're using a pre-coat. All right, let's talk about binder real quick. The functions and characteristics. What does the binder do? The binder is there to seal the road. What's the enemy of this road? Water. All right. In engineering school, that was the 3 words we needed to know. Drainage, drainage, drainage. That was it. That's the most important part. Keep the water out of your base. Okay? So we want to use that binder, whether it's hot applied, emulsion, we want that to seal those cracks and basically waterproof that surface. Okay? But we got a few things we need it to do. We need it to be viscous, but not too viscous. We don't need it to be too thin. We need it to be able to get out of the distributor. Okay? If we spray it out of the distributor and we see it running off the side of the road, is that good? No, that's too thin. Why go any further? Don't go any further. Okay? Yet we don't want it too thick or it won't come out of the distributor. We want it to have some body to it so it can hold a rock. But we're going to be applying a pretty good amount of binder or emulsion on this road. Okay? So some of the types, we have hot AC. That can be modified, tire rubber, polymer. We've got cutback. Then we have emulsion that's unmodified and modified. Now, who in here does hot applieds? Okay, hot applieds. Can anybody do cutbacks in here? All right, I didn't have anybody yesterday either. And then emulsion. Who does emulsions in here? Okay. So we can have just like a regular RS2, CRS2, or we can have maybe a CRS2P. It's got some polymer in it. So what are some of the advantages and disadvantages of each? Well, I mean, one of the advantages with the hot AC is it's little to no curing period. I mean, we're ready to go as soon as it comes out. It's a quick return to traffic, and it has great aesthetics because you're usually using pre-coated aggregate. So it's going to look dark once you're finished. Going to make that striping pop. Everything's going to look good. They're going to think it's a hot mix road probably. Okay? But some of the disadvantages might be that you are dealing with a hot binder. Anybody ever seen anybody got burned by asphalt? 350-degree asphalt? It's not pretty. When you get it on you, you can't get it off you. I mean, you cannot get it off you, right? So that is one of the disadvantages there. And then, you know, you got sensitivity to moisture and then just the cost of pre-coated ag. So if we're going pre-coated aggregate way, there is a little bit more cost there for the pre-coated aggregate. So let's talk about emulsion, some of the advantages there. Well, we have lower application temperatures because we have water in that emulsion. That's the conveyance method to get that asphalt out there. We're using water to get it out there, okay? So now we're looking at an emulsion at 160 degrees, 165 degrees, so a lot cooler than a hot AC, but still hot. I mean, it'll still burn you a little bit, but it's just not gonna be as hot. We don't have to use pre-coated ag, but one of the big disadvantages is we are gonna have that curing period there. It's not gonna be a real quick return to traffic. You can, that's where we get into some of the polymers, but you're gonna have to let it cure a little bit, okay? Whether that's an hour, 2 hours, 6 hours, whatever that is, a lot of that depends on your environment that you're in, but you are gonna have to wait. And here's a listing of some of the cationics and anionics. So what does the RS stand for? Rapid set? Yep. What does the 2 mean? Viscosity, yes. So a 2 is a high viscosity emulsion. And if you ever see a 1, like a CSS1, like TAC, it's thin, or it's a low viscosity. Okay, so we could categorize these as maybe anywhere from 100 seconds to 400 seconds in viscosity. Okay, tested in the lab. All right. But we have considerations when we pick a binder. I mean, a lot of times when we pick a binder, it's because that's what's readily available. It's kind of like aggregate. Whatever my manufacturer is making, that's what I'm probably going to have to use. But in some cases, I might have a choice. I might have somebody that's doing hot applied. I might have emulsions out there. There's considerations for that because each of them have a temperature requirement or what they're recommended to be used at. Not only air temperature, but surface temperature. That is the one that kind of is the forgotten one. Everybody hones in on air temperature and they're just waiting on it to turn 60 degrees or 70 degrees and then I can go, but my project's in the shade. So what do we think that temperature on the road is? Is it the same as the air temperature? No. We need to have both of them done. Both of them need to meet that requirement. Traffic volume, another consideration. So if I'm on an interstate in Texas or a roadway that has 100,000 vehicles a day on it or 10,000 vehicles a day on it, might be a little different binder I use there versus one that only has 3 houses on it. Where somebody's gone, there's nobody driving down this road for 6 hours, right? That might be a consideration. Might be able to use one that's, let's just say an emulsion that's unmodified. It costs me less. It costs more to use modified materials usually. So if I'm gonna put that cost into that emulsion, I need to make sure I get some value out of it. So now we're starting to see more chip seal designs. And it's simply just a starting point for where our application rates need to be. There's a couple different methods, or a couple common methods, the McLeod method and the modified Kirby method. So the McLeod method is more, it's really based out of, I say, MnDOT, Minnesota. Minnesota does a really good job of explaining the McLeod method. So you can go to their website or you can Google MnDOT chip seal design and it'll bring you up their guide, their manual. And it's really, really good. There's also a little spreadsheet out there as well that will help you decide where those application points need to be. But it's based on 2 principles. Number 1, it's 1 stone thick. Number 2, that all the aggregate is 70% embedded. Why would we want it to be 70% embedded? And not 50%, let's say. Why couldn't I do it 50%? What's different about Minnesota, places like Minnesota? What are we worried about? Freeze thaw, snow plows coming through and wrecking on my rock, taking it up. So maybe I need to make sure that my rock is a little bit more embedded in the north where I get a lot of snow. Now, I can't say that, I'm from Mississippi. We've had 2 snow events in the last month. So maybe we should bump up our chip seals, right? But when we go further south, our chances of snow and snow plows are very small. So we usually use like 50% down there for our designs. Kind of gives us a quick dirty. But it's all dependent upon really the factors we talked about earlier on aggregate, gradation, the shape, what does your flat and elongated look like, or the flakiness index, bulk unit weight, specific gravity. If we can find all those measurables or metrics out on our aggregate, then we can plug them in very easily into this spreadsheet, and it'll basically tell us how much binder we need to stick that rock. Okay? On the modified curbing method, this is more of a TxDOT method, or the state that uses it the most is TxDOT or Texas. They also have a seal coat manual. Very good, free. If you Google TxDOT seal coat manual, it's not a chip seal manual in Texas, it's seal coat. Now, they got to be a little bit different. We got any people from Texas in here? Okay, so nobody's mad at me. All right, so it's really designed more for AC, hot AC. Okay, so you have to use some adjustments. They have little adjustment factors in there if you're going to use emulsions. But a lot of the same factors that you used in the McLeod method, you use in the curbing method. Now they have one little deal with what they call a board test, where they're going to physically put aggregate out on this 1 square yard of plywood, 1 stone thick. And then once they get all that covered, they're going to put it in a bucket and weigh it. And that's going to be your poundage per square yard. Pretty simple, pretty easy. Okay? So we also got, the binder is, basically based on the embedment depth. And you've got traffic volume, existing surface condition. So if I have a slightly flushed surface out there, maybe I don't need to put as much binder on the road. If it's pocked and porous, maybe I need to put a little bit more binder on the road. Traffic volume can come into play as well. So on that little spreadsheet that MnDOT has, it actually prints out a graph for you, and it tells you, okay, if you got this many cars per day, it's here. If it's this many cars a day, it goes up a little bit, up a little bit. So it kind of gives you some adjustments depending on what the traffic is. Okay? One of the things I'll say about existing surface condition is when we see more and more are these full width patching or leveling out on the roadway, and they go for a long way. Okay? So we've got a design based on an existing surface condition, but right before we get to do it, they go out and level the road, put a bunch of new hot mix on the road. So we're going to use our binder rate. What happens to our binder when we apply it to this fresh leveling or patching? It absorbs it. It's thirsty. It goes right down into the leveling. And then what happens? Put my aggregate down. I use the calculator. Everything's good. I put it down, and I come back and my rock's on the side of the road. Why is that? Well, it just didn't have enough binder. So we're really preaching more now about if you've got patches, you've got leveling out there, there's nothing wrong with that. You just need to take that into account. So one or two things need to happen. Either you need to spray more binder on the road when you're going down the road with your distributor, or you need to go out and fog seal it before you even start. Seal off those patches. Yes? I would just fog seal it. That's easier. Yeah, easy, yeah. The only problem that we get into sometimes is that if the job is set up and it had leveling or patching in it, the engineer might not have it set up for fog seal. And so then you run into the case of you might not get paid to fog seal it. But it could be in your best interest to fog seal it. It's pretty cheap insurance out there. So that's one thing, like at agencies, if you're going to be doing a lot of patching or leveling, does not hurt to put a little bit of fog seal in there. It's cheap insurance to make sure you seal off that brand new pavement. Okay. This was a slide that was in Tom Wood's presentation a few years ago. I just put in there just some rules of thumb, like, you know, 0.01 gallons of binder equals 1 pound of aggregate. So if you're using application rate of 0.35, it's 35 pounds of aggregate. Get you close. I thought that was pretty neat. So I just threw that in there. These are the links, and somebody asked about the presentation earlier. We should have it available. It'll be out there on the web, and these are the links there. Like I said, you can Google a lot of this stuff and find it, whether it's MnDOT, TxDOT. There's also the webinar that I mentioned. I did one for Asphalt Institute a few years ago on just chip seal design, and we did the McLeod method. So I went through basically the whole book from MnDOT. So it's on the webinar. Okay.
Morning, everybody. I'm Brian Horner. I'm with Etnire. I've been around Etnire for 30 plus years. I know I don't look that old, but I started when I was real young. So, but anyhow, we're going to talk about distributors. We're going to talk about the equipment on a chip seal job. So we'll get into brooms and rollers and distributors and chip spreaders, and we'll talk in depth a little bit about the distributors and calibration and how to check calibration, stuff like that, where we run into issues with it, maybe a few problems on job sites. So any questions that you have, feel free to ask them at any time. But on a chip seal train, that's what we call it, the chip seal train. Normally you're going to broom out front, make sure that all the dirt and dust is off that road so our binder has a chance to stick. We're going to follow it with the distributor truck and spray in that metered application that we want. Then we're going to follow that with a chip spreader, hopefully fairly close. We don't want a big distance between our chip spreader and our distributor. And then we're going to roll it. And we want to roll it as quickly as we can to get those rocks pushed down and oriented into that binder accordingly. So mainly power brooms are out there. In my experience, you want to sweep that road, blade the edges back if you can to make sure you're sealing all the way out to the edge, because vegetation starts to grow in and our roads just get smaller and smaller and smaller. So we want to blade that stuff back, then we want to sweep it real well. Then we're going to follow it with the distributor truck, spraying at the metered application, followed by a chip spreader, whether we're doing single lane or full width. How many people do full width chipping? Okay. There's advantages and disadvantages to full width chipping. The biggest advantage to me in full width chipping is we get rid of the center seam, and that's normally where our failures are, or when we do that overlap. So we get rid of that. There's a few disadvantages to it. You got to think a little bit more where you stockpile and how you bring your trucks in. Sometimes people are worried about traffic control on full width. They just say they can't shut the road down. But if you're in a situation, and we've done the study, if you're running a pilot car so that you're stopping traffic, even though, to let cars stop so you can pull around the chip seal train, if you're doing full width, Missouri does this a lot. They'll allow you to chip seal for 20 minutes, and then you have to pull off. You do it full width, and then let traffic do its thing, and then shut it down for 20 minutes. And they found that they're holding drivers up less time by doing that than running a pilot car situation. And they feel they get a better job because it's uniform all the way across, and they get rid of that center seam. Then we're going to roll our chip seal with a pneumatic roller. What about our metered application? That's really what we're here to talk about. How do we get what the method or the design that we're asking for, how do we get it on the road? What goes into a distributor to do that? You're going to figure out what you want for an application rate, right? Somebody's going to tell you that. Okay. Now what speed do I drive, and what does my pump need to turn in order to get the application at the width or the number of feet I've turned on my bar? How does all that work? Well, it's actually very simple. You can get a metered application in different ways. You can do it this way if you wish. I'd prefer coming out of the back end of a distributor. It's a little cleaner and a little less work. You can use the calculated eye, which Larry pointed out that we used to do. I mean, a lot of guys could actually look at the road and say, yeah, that's 35 hundredths, and he would be pretty accurate because he's done it for 20 or 30 years. Now it's punch the number into the computer and hope everything is set right in our gallons per square yard. Is anybody using metric? Nobody's doing metric? You're doing metric? In liters per square meter? So on distributors, even from the beginning of '93 when we started, all of our distributors are capable of shooting metric. You just have to go into the computer and flip a switch to change it over from gallons per square yard to liters per square meter. So if you ever get any jobs that need the metric, you can actually shoot in metric. But here's your 4 things. The faster I drive or the slower I drive, my pump changes in order to get my gallons per square yard I want. If I change my spray bar width while I'm spraying, my computer sees that, changes my pump to give me that same rate. If I change my rate, distributors, Larry was talking about going over those patches. Every distributor has a series of memories in the computer, maybe 5, maybe 10, depending on what brand you have or what model. But you can change the application rate while you're spraying. So a lot of times guys will set up, if my job calls for 3/500ths of a gallon per square yard, and I come across one of those patches Larry was talking about, and I need 4/10ths, we just set a memory at 35 and 4, and as I'm driving along, I can reach over and hit that memory, and in an instant, the pump speeds up and gives me 4/10ths. I get past that patch, I hit the next memory, and it slows back down to my 3/500ths. Now, I would not suggest that an operator, you'll drive a chip spreader guy crazy if you continually punch those buttons, but for those long patches, or maybe you hit a concrete section or something, maybe you want to back that oil down a little bit because it's not going to soak up at all. So you can change your application rates as you go to vary for your road conditions. It's all based off of ground speed. Now on Bearcats, they put a sensor in the rear axle that's counting the rear end of the truck to tell us how fast we're going. That's what's feeding their computer. In an Etnire, we use a radar. But in both cases, if we're not getting the correct ground speed and the correct distance, our computer's not putting out the application that we're asking it to give. So radars become very important. We have asphalt pumps that have speed sensors on them so that we're counting revolutions of our pump. On a Bearcat, every time that pump turns 1 revolution, they know that they're getting 1 gallon of oil out of that. And at Etnire, we're getting 0.61 gallons of oil. So our pump actually turns a little bit faster, but it's just a way to count the revolutions to feed back into our computer. Anybody use? But on your settings of your spray bar, in CHIPSEAL, we want triple overlap. That's what every manufacturer of a distributor looks at. Nozzles are on 4-inch centers, so that gives us triple overlap. We want 12 inches from the bottom of the nozzle to the ground, so our fan is 12 inches at the base, which then turns and gives us our perfect triple lap over application. That's what we're after. So if you have your wing, if you've got a big crowned road and you're doing full width and your center bar is 12 inches off of the road, and maybe it's less because there's so much crown, and your wing is 3 foot off the shoulder, you're not getting uniform application out there. So we need to crown that bar down a little bit and make sure we try to maintain as close to that 12 inches as we can to get triple overlap. The nozzles are really important. We used to use what we call coin slots, the one on the right, just a slit in a nozzle. Okay, they work fine for hot applieds, but they don't work very well for emulsions because emulsion tends to stick to the edges of the nozzle, and you get these really heavy edges and not good uniform in the center. So everybody uses a football shaped, a cat's eye, a multi-slot, a V-jet, whatever you want to call them. But if you look inside the slit of the nozzle, you'll see that it's a football shaped orifice in there. That's what we need for emulsions. And they work for hot oils too, so most people don't use coin slots anymore at all. But they all need to be set at the right angle. If my nozzles are all twisted on my spray bar, I'm getting the right volume still, but I'm not getting a good pattern. So I want to set those at 30 degrees all the way across the bar. And we send this little wrench with you so you can put it on the nozzle and touch the next one, so that sets our 30 degrees. And it doesn't matter if the 30 degrees are slanted the way that picture shows or the opposite. as long as all my nozzles on my bar are set at 30 degrees. That gives me my triple overlap. Lots of different nozzles out there. Okay, we can pick small ones, big ones, little ones. Here's another way to figure out how I should drive my distributor. If I don't want to look at that app and go by speed, get that speed range in there, I can do it by gallons per minute. Because I don't even look anymore at the application rate a nozzle will give me. I don't know if it's not false information, but it's misleading information. We look at how much oil, how much product that nozzle will actually flow at a minimum and a maximum and still give you a fan. So we basically take and multiply how wide we want to go times the minimum and maximum of that nozzle, and that gives us a gallon per minute range. On a job, to check volume of what we sprayed, the most accurate way and the simplest way is use the measuring stick. It comes with every distributor truck. On an Etnire, you put it in the manhole and you just touch the top of the oil and you read at the very top of that tells me how much oil is in that. So if I was gonna, and I've done this a lot, make sure everything's all right volume-wise, park your distributor truck somewhere, put a couple paint marks where your tires were at, stick your tank, go spray for a while, come back, put it in that same spot, re-stick the tank, and see if my gallons that I still have left or that I used matches what I should have shot. That's the easiest way to check the volume calibration on a distributor. You have to realize that those sticks are specific for a certain tank size, okay? So you can't just take a stick and use on any distributor because we have to know what the size of that tank is. Is it this big, this wide, this tall? So there are for every distributor. A Bearcat does it just the opposite. It's not reverse calibrated. You put the stick in the manhole all the way to the bottom of the tank and pull it out, and wherever the oil line is what you got left in that tank. Then you got to wipe the stick off. Etnires just reverse it so we don't have to get the stick dirty is the only reason for that. But that's one way to check it. Another way to check it, is by weight. If you're a contractor in Chicago, there's no chip seal in Chicago, it's all paving, but you have to spray tack for that paving. The state pays you by the pound, okay, of residual asphalt. So they want a ticket. So you go drive into Chicago, your asphalt plant's out on the edge of Chicago because there's none in the city. You drive in, you spray a few hundred gallons, and then you have to go all the way back out to your plant and reweigh to give them a ticket that says, I shot this much by weight. We actually put weigh scales on distributors now, certified weigh scales. They're expensive and they have to be calibrated and certified by the state to where it will print a ticket off in the cab that will tell you today's date, temperature of the oil, how many gallons, how many pounds, all that stuff's on a certified ticket and you can hand it to somebody and go. But that's not practical in most jobs, but it is a way to check the calibration of that distributor. The other way is a longitudinal test. Anybody do a test like this before? Yeah, you're spraying over some pre-weighed pads, you're reweighing them after you spray, and by weight, you're figuring out is the volume coming out of that spray bar correct. Now the longitudinal test will tell you not only is the volume correct, but it will also show you that I'm getting consistent all the way across the bar. The other methods I showed you, the weight and the stick, is just going to tell me I shot the right amount. It doesn't mean I actually got it equal all the way across the spray bar. But longitudinal tests are very popular. If I am a contractor and an agency requires a longitudinal test and they're doing that, I would do one myself also so I can verify their results versus mine because, if somebody doesn't, they dump some off the pad or they mix them up and, you can get different numbers there. The rest of this goes pretty fast because chip spreaders are pretty simple, okay? What did we talk about at the break? What's the job of a chip spreader operator? Cover up the distributor operator's mistakes. That's all he does all day long, okay? But the trouble is if the distributor operator makes a mistake, he can cover it up for so long, but because chip seal's one rock thick, you're going to see that mistake later. So you can only hide it so long. So you can do single width boxes that we have out there. We got full width boxes that cover everything all in one pass to get rid of that center seam. But the chip spreader basically is to apply that aggregate at a uniform application so we can save money. We want that rock to be the minimum amount. If your design says it should be 30 pounds and we calibrated our chip spreader so we're getting 30 pounds, I'll almost guarantee you that in the real world you're not going to spread 30 pounds. That's going to come down to 28 or 26 or 22, because even though we're putting that uniform rate on there and we're set it as a design, we still want one rock thick, and we want what we call a salt and pepper look. We want to see a little oil when you look down around those rocks, so when they get rolled, they have a place to roll into the binder so they're able to stick. If they allow me to do this on a job, I will start out a little heavy and I'll keep backing it down until I start to track a little bit, and then I bring it up to my tracking stops, and that's where I want to be. Because you don't want excess rock out there that you're going to have to broom off. That just costs you time and money and windshields. So we want to put down the right amount, but I've never found a spec yet on the McLeod or whatever that we actually put down that amount of stone. It always tends to be a little lighter. So the gate openings, the computer settings, the conveyor speeds, the augers, and the tire pressure are all part of calibration. And why does any of that matter in calibration? Well, if my gates aren't set correctly and I'm out of range, I may get to a certain speed that my gates can't open anymore. And now all of a sudden my rock is light. So we have to calibrate according to a speed and the size of that material. So that's how the computer comes in. My conveyors and my augers, okay? You don't want them to turn off and on, off and on, off and on, off and on. You want them to run continuously if you can. In a perfect world, if I started the chip and I got the dump truck in there and I'm running down the road, I don't want anything to shut off. Okay, that's the perfect world. As long as I'm feeding that machine and getting the rock out there, it's easier on your hydraulics if you're not turning them off and on. So if anybody got a variable hopper, Bearcat or Etnire? Okay. If I'm running full width, I may have them augers turned all the way up to get that material out to that width I want. But all of a sudden I'm doing a 12-foot lane and I suck that thing in, I probably want to slow my augers down, otherwise they're going to turn off and on and off and on. And they just keep doing this, and that's just hard on hydraulics. So we want them to run and shut off, run and shut off. So, and then what about tire pressure? Why do we care about tire pressure? There's no suspension on a chip spreader, okay? So if I got my tires pumped up to 120 pounds and I hit a little bump, it bounces the machine a little bit and I start making those washboards or rub boards in my road. So the tire pressure needs to be set down 65, 70 PSI so that I got a little softness to those tires, so when I hit a little imperfection in that road, I'm not starting to make it bounce. So that's why tire pressure becomes part of calibration. How do we calibrate it? We actually chip over a 3-foot by 3-foot tarp and we weigh it, okay? We set on our computer, let's say we want 25 pounds. We set our computer at 25 pounds, 3/8 chips, and we set a speed that we want to go as our cruise control, our maximum, so we can just shove the stick forward and go, and we run over those tarps, we weigh it. This is coming out to be 21.5, but I got to deduct 2 pounds for the weight of the tarp. So really I'm only getting 19.5 pounds, but I wanted 25. So I need to go into the computer and say, hey, I'm a little short, and add a few pounds to it, hit the save button, do it again, do a few different passes until I get what's on my screen is actually what I'm getting on the ground. Now we can use the calculated eye. Now we're where we want to be. So as I speed up and slow down, my gates will open and close, but if I need less or more rock on the road, when I adjust my rate switch on my computer and say I need a little bit more, it opens up a little bit more and I'm all within range. So it's just You can run a chip spreader without ever calibrating it, just use your eye. But if I get out of whack, I may run into that situation where I push the stick forward and the computer says, I can't make it go any wider because you're telling me I'm at my max. And then you can't get your rate. So I would every rock is different. So a 3/8 chips from Bill's quarry may calibrate different than 3/8 chips from Ron's quarry. So there's memories there you can save for different sizes, or maybe 3/8 chips versus one quarry or the other. When we're talking about distributor mistakes, I set two memories together. Well, if I want 22 pounds on my main road, I set it at 22 pounds and everything looks great. Then I set the next memory at maybe a little slower speed, and I set it maybe at 24 or 25 pounds. And why do I do that? Because when you do a radius, the distributor always tends to overlap, right? No distributor operator is perfect to give you the exact amount of oil on a radius. He's going to overlap a little, and a lot of times you chip through that and you're bleeding a little, so then you chip it again. Well, if you just went to a different memory and say, I'm going to put a little more rock on that radius, then you don't have to chip it twice. So it's easy to change those memories back and forth. What about rolling? Jason's going to talk about rolling. He's going to do the construction end, but rolling, we talked a little bit about that earlier, is very important to a chip seal. This is a very good thing. They got a couple trucks in between the chipper and the rollers. You want to be able to, you don't want 15 trucks in line and then your rollers. How many rollers do you need on a job? Depends on how fast your chip seal train is going. You don't want your rollers 3 miles behind you because the oil's setting up too much before it gets rolled. You want those rollers close. Jason will talk about tire pressure and all that stuff, but your dump trucks are basically your best rollers. They're the ones that are on the job first. Stagger those wheel paths, okay, so you're not driving in the same path, and let those big dump trucks be your first roller on the job. That will help. So dump trucks, stagger your wheel paths, keep them at a slow speed. Try to plan your jobs, whether you stockpile or pulling out of a quarry. So if you're doing one lane at a time, your dump truck's always coming in from the head of the job so he can pull in behind loaded and back up to the chip spreader and not have to turn around on your fresh chip seal and scuff it all up. If you're doing full width, now you're closing the road down to a certain point, so now maybe I got to come in from a different way. I can't always come in from the same direction. So you always want to chip seal away from your stockpiles, okay? Brooming, Jason will talk about that, but chip seals on brooms, most people need to or should, but if we keep that rock to a minimum, we don't have a lot of brooming to do, okay? If we're starting to, I always say, you're not trying to shoulder your road when you chip seal it. So I don't want to broom everything off and put rock in my shoulder because I wanted to shoulder the road. That's not what chip seal rock is for. So try to keep the rock down so we have a lot less brooming. So not your job. You can get a hold of us anytime. Give us a call.